Hello everyone and welcome to this session on mixtures and solutions. In this video tutorial, we'll quickly take a look at a basic concept called alligation, which is extremely useful to solve various types of questions in mixtures and solutions. We'll also take a look at some very basic methods to solve questions of these type. So what is mixtures and solutions all about? Well, basically it's a combination of three different topics. So if you're comfortable with the concept of what is percentages, if you're comfortable with the topic of what is averages, and if you're comfortable with the topic of ratio and proportion, then mixtures and solutions should not be very difficult for you. So let's typically take a look at a question which is of mixtures and solutions. Let's say that in what proportion must a solution containing 40% alcohol be added to a solution containing 60% alcohol to get a solution containing 50% alcohol? Well, if you have understood this question, then we can simply look at it and say that 50 is the simple average of 40 and 60. So if I am adding a solution of 40% alcohol and one of 60% alcohol, then just add the two original solutions in the ratio of 1:1 and the resultant solution will contain 50% alcohol. You can check it with numbers. Let us say there is 100 ml of the 40% solution and 100 ml of the second. So the first one contains 40 ml alcohol, second contains 60 ml alcohol. So if I add the two, I get 40 plus 60, 100 ml of alcohol in a 100 plus 100, 200 ml solution, which is 50%. So this is extremely basic. But then you can get a twist in the question, which is the more common type of question which can come in mixtures and solutions. So with a slight twist in the numbers, let us say it is asked, in what proportion must a solution containing 40% alcohol be added to a solution containing 80% alcohol to get a solution containing 50% alcohol? Now, 50 is not the simple average of 40 and 80. So then how do we get the ratio in which to add the two solutions? Well, first let me show you the technique and then the explanation of the technique called alligation. So how do we use the method called alligation? Well, here it is. We are given that solution 1 contains 40% and solution 2 contains 80%, right? And when we mix both of them, we are required to get the solution which contains 50% of alcohol in it. So what we do is, from the left we subtract the two numbers. The difference of 40 and 50 we get as 10. Now we cross and get the difference between the other two, that is 50 and 80, which is 30. So as you can see, the difference between 40 and 50, 10 we write on the other side. The difference between 50 and 80, 30 we write on the first side. So 30 and 10, which is the ratio of 3:1, is the answer. So if the first solution is in the proportion of 3 and the second solution is in the proportion of 1, then the resultant solution will have 50% of alcohol in it. You can use some numbers and you can verify this result. So this simple crisscrossing technique that I used right here is the one called alligation. So for those who are mathematically inclined and love to watch and read and remember formulas, here's how it works. When two or more quantities are mixed together in different ratios to form a mixture, the ratio of the quantities of the two constituents is given by this formula. QC by QD is D minus M, the whole divided by M minus C, where QC is the cheaper quantity and QD is the dearer quantity. In the previous example, the cheaper quantity was the one with lesser concentration of alcohol, the dearer one was the one with the higher concentration of alcohol. In the formula, C stands for the cost price of the unit quantity of the first element, D stands for the cost price of the unit quantity of the second element, and M is the mean or the average price. Now, price was when it comes to terms of money. In the previous example, the exact same formula could be used, where instead of price we talk about the concentration, the percentage of alcohol strength in the solution. So let us take a look at some examples and see how we can use either alligation or an easier method to get the right answer. Let us say it's asked, how much tea worth rupees 25 must be mixed with 20 kgs of tea worth rupees 30 to sell the entire mixture at 27 per kg and incur neither profit nor loss. So I have got my cheaper tea which is at 25 rupees and I have got dearer tea which is worth 30 rupees. Now the average price at which I intend to sell them is 27, and here there is no profit or loss. So using alligation, the difference between 25 and 27 is 2. The difference between 27 and 30 is 3. So the cheaper should be in the ratio of 3 to the dearer's ratio of 2. Now it's already given that the dearer one, that is the one at rupees 30, is 20 kgs. So I should sell 30 kgs of the first one mixed with 20 kgs of the second one. The ratio 3 is to 2, so that the entire thing averages out at 27. And this is how we use alligation. Now it said how much water must be added to 14 liters of milk worth rupees 5.4 a liter, so that the value of the mixture may result in rupees 4.2 a liter. Okay, now I know that milk is one of the quantities, water is the other. I know that milk is worth 5.4 a liter, and when it is not given, we assume that water is free of cost. Now when I mix the two of them, it should be evaluated at 4.2. So the difference between 5.4 and 4.2 is 1.2. The difference between 4.2 and 0 is 4.2. So the two things must be mixed in the ratio of 4.2 is to 1.2. Now if I boil this down to numbers, I get the ratio is 7 is to 2, which means for every 7 liters of milk I need 2 liters of water. But it's given that there are 14 liters of milk. So if 14 liters of milk is in the solution, I need 4 liters of water, and that should be the right answer. Okay, in what ratio should two varieties of tea, one costing 25 and the other costing 30, should be blended to produce the blended variety worth 28? Now that we have got a hang of alligation, 25 and 30 are the two teas, 28 is the mean price, difference of 25 and 28 is 3, difference of 28 and 30 is 2, so they must be mixed in the ratio of 2 is to 3. See how simple alligation is actually. Okay, now in an exam out of 480 students, 85% of the girls and 70% of the boys passed. So how many boys appeared in the exam if the total pass percentage was 75? Well, girls and boys, girls is 85%, boys is 70%. For the total, the pass percentage works out to be 75. So 85 and 75, the difference is 10, 75 and 70, the difference is 5. So girls to boys are in the ratio of 1 is to 2. Adding them up, the total is 3. Now I know that there are total 480 students, which is 3. So I get 3 into 160 is 480. So boys who are in the ratio of 2, when multiplied by 160, give me 320. And there are 320 boys. If it was asked how many girls were there, we multiply 1 by 160 and we get 160 girls. Add the two of them, total is 480. See, that's simple. Okay, in what proportion must tea worth 75 paise per packet be mixed with tea worth 5 rupees 50 paise or 550 paise per packet, so that the mixture may cost 450 per packet? Okay, so again using the fundamentals of alligation, the difference between 450 and 75 is 375. The difference between 450 and 550 is 100. So the ratio is 100 is to 375. So if I simplify this, I get the ratio as 25 4s are 100, 25 1s are 375, 25 5s are 125. The ratio is 4 is to 15, which is my second option. Now, in what ratio must water be added to spirit to gain 10% by selling it at the cost price? Which means when I am actually selling it at rupees 110, my cost price is actually only 100, which means I am professing that I am selling you exactly worth 110, but I am actually selling you worth only 100, which means 1/10 of the entire quantity of my cost is purely water, which means I need to add 1 water to every 10 units of milk, so that 1/10 is what I earn, and that is your answer. Okay. Now here is an example where instead of using alligation, let me show you one other simple method which I call the table method and explain how to solve it. It says 300 grams of salt has 40% of salt in it, which means let's assume that the solution has salt and water, which makes up the solution. Now it says it has 40% of salt, which means 60% must be water, which makes up the total 100%. Now as the total amount is actually 300 grams, 100 threes are 300, so 40 threes are 120 grams and 60 threes are 180 grams. Now it says how much salt should be added to make it 50%. I'm simply adding salt, which means my water remains at 120 grams, and if salt is 50%, that means water is also 50%, which means they are equal in quantity. So from 120, if I want to bring salt to 180, I simply need 60 grams more. So 60 gram of salt being added to the solution makes it a 50% solution. See, simple. Okay. Using the same method, let me solve one more example. Now this is of milk and water, which gives me the total solution. So it says 729 ml of a mixture contains milk and water in the ratio of 7:2. Now if 7:2 is the ratio, the total is 9, and I know that 9 multiplied by 81 gives me 729. So 81 is my multiplication factor. So 9 into 81 is 729, which means milk is also 7 multiplied by 81, which adds up to 7 ones are 7, 8 7s are 56, and water, which adds up to 2 ones are 2, 2 8s are 16. So 567 plus 162 also adds up to 729. Now it says how much more water is to be added to the mixture to get milk and water in the ratio of 7:3. Now if water is being added, it means that milk is still remaining at 567, but now the ratio is 7:3. Now I already know that 7 multiplied by 81 was 567. So using 81, I get 81 threes are 3 ones are 3, 8 threes are 24. That means water now needs to be 243. Already I have 162 as the amount of water. So 3 minus 2, 1, 24 minus 16, 81. If I add 81 ml of water, then I jack up the percentage ratio as 7:3. So the answer in this case is 81 ml. See what I did? I simply used the concept of multiplication factor and play around with the ratios to get the answer. Now, let's say it said a person has a chemical of rupees 25 per liter. In what ratio should water be mixed so that after selling the mixture at rupees 20 per liter, he gets a profit of 25%, which means if he's selling the mixture at rupees 20, his selling price is 20 rupees, and he's still getting a profit percentage of 25%, which means his cost price should be equal to 4/5 of 20, which is equal to 16, right? So his cost is only 16 rupees. So the chemical is worth rupees 25 per liter. He has to say that he's selling at 25 per liter, but he should get only 16 worth put in the mixture. So he uses only 16 rupees worth. He adds free stuff, that is water, worth 9. So it seems as if it is worth 25 rupees. So when he sells it in the ratio of 16:9 at rupees 20, he has actually incurred a cost of only 16, which still gives him a profit percentage of 25%. So my answer is 16:9. So let us have a quick recap of whatever we learned so far, right? Remember, mixtures and solutions is nothing but a combination of percentages, averages and ratio proportion. If you learn how to play along with these numbers, it's extremely easy to get the concepts. Remember alligation. It's not difficult to remember the formula, but you don't need to remember the formula. Simply remember how to use the crisscross technique that I showed and your work is totally done. This was a video tutorial from the subject of mathematics on the topic mixtures and solutions. My name is N. Sathya. Wish you all the best. Have a good day.